Looking at assignment 3, starting with question 1, we're asked to look at this question. It's in an electronics laboratory. A technician is needed to provide students the value resistors from an E-series. We're given a series of values for those resistors that are available in the stockroom: 1 ohm, 5 ohms, 10 ohms, 20 ohms, and 50 ohms. Required to write a C program. It takes the requested resistance as an input and calculates how many resistors of each denomination and technician should give out for this operation. So we're going to use only requirements are basic arithmetic operations in the code. We have a resistance value that we want is 689, and then we'll figure out from there what resistors are needed. Starting out, we're going to declare the values. We're given this in the problem that we have a value of 50 ohms, 20 ohms, 10 ohms, 5 ohms, and 1 ohm. So we're going to declare those as R. One's going to be for the remainder, and the rest of the values are going to be for the individual resistors. Next step is we want to print how many ohms are going to be entered. We know this is going to be 689. And then we're going to scan those values for the declared ones at the bottom. So declaring for each value, we have resistor 50 on line 13. We have a declared value of R minus the resistor 50 times the 50 ohms to be able to get the value of what resistor we need. Similarly, we declare for 20 ohms, so we have R divided by 20, and then we declare for the remainder R, which is R minus 20, and then times 20. Similarly, for 10 ohms, we have R divided by 10 for 10 ohms. And then we have the remainder, which is R minus R10 times the value of 10. Determine what the number is going to be. Do similarly for 5 ohms, for R divided by 5. And then for the remainder, we have R minus R5 times 5. Since 1 is divisible by itself and will be multiplied by itself, all we need to do is set the resistor for 1 ohm to the remainder, which is R, and that'll be our leftover. To generate the values, we want to printf for the message. Display the message. You'll receive the following resistors for the technician, so you can grab those. And then for each of the resistors that he will need, 50, 20, 10, 5, and 1, we do a separate display message with each value as a individual line item. So after this explanation, we're going to run the code. We know that this is going to be 689. Number of resistors that are going to be received is a number for 50 ohms is 13. Number for 20 ohms is 1. Number for 10 ohms is 1. And the number for 5 ohms is 1. Number for 1 ohm is 4. So this matches to the sample runs that we were given. So we know the code is working and that the values were built and declared correctly to be able to run this. Okay, moving on to question 2. In a digital communication system, codes are often represented as a sequence of digits, where each digit may correspond to a significant level or configuration value. We're seeing that this is a 6-digit code. So we'll have a 6-digit code that's built upon with a digit added to each code value in the original 6-digit code, and it'll be updated with that value. Some requirements for creating this is that we want to assume that the first digit of the code will not be 9, so that the updated code will remain a 6-digit number, so it won't go to a 7-digit number. We are given that we are only going to use 5 arithmetic operators and no other special characters. So setting this up, we want to include the studio, and we want to include library for math, because we are going to have some values in here and some operators that are easier to input from the math library. So declaring what the integers are, we have the code, we have D1, D2, D3, 4, 5, and 6 for the individual numbers for the 6-digit code, for the original 6-digit code. Initially, we are going to print whatever the number is. The operator is going to enter the number, and it's going to scan the code for the values of the original code, which is 393201. Next step is we're going to extract each digit from the code. We already declared the values up here, and then we're going to use modulus to divide these out by tens, so the remainder of 10, so that we can pull each digit from this original code. We want to add an additional number 1 to each of those extracted values to be able to update our new code. And to do this, we'll do the original value plus 1, and then using the modulus and wrapping that value to ensure that we're getting an updated value, and we're using a modulus and 10, similar to above. Next step is we want to organize the new numbers in a correct order. So since these have 6 places, we'll multiply times 100,000 for D1 to be able to get a character in the 100,000th place. Similarly, D2 is 10,000, so we'll get a character in the 10,000th place. D3 is going to be at 1,000, so we'll get a character in the 1,000th place. D4 is 100th in the 100th place. D5 is in the 10th place, and D6, since it'll be in the first spot, we don't need a multiplier. And then we're going to display what the updated code is and the code. So now we're going to run. We're going to enter the original 6-digit number, which is 393201. And we can see that the code is 404312, which matches to the code that we want to receive if each digit has 1 added to it. All right, moving to question 3. Because we're looking at both letters and numbers and symbols for this problem, it's going to be a little bit different than using traditional integers. So to start, we're saying we're designing a synonym classifier, and we want to use build a program to analyze the characters' values that are from the AIC2 tables and classify the type of the input. First requirements here is if the input is a digit, 0 to 9, we want to display it's a number. If it's a uppercase letter, A through Z, we want to check to see if it's a vowel or a consonant and display a message that would match either or. Similarly, we want to do the same for a lowercase value. Check to see if it's a vowel or a consonant. And then the last is if it doesn't match any of those as above, then it's going to be a special symbol. So we don't want to use integer in here because we're not dealing with just standalone numbers. So we're going to use a character and declare it as C for character. We want to do printf, and then we want to scan those values to be able to have an entry. And if the input is a digit between 0 and 9, then we're going to display its number. Then if the input is an uppercase letter A through Z, then we would check it's a vowel or consonant. We're going to really call this C2, character 2, just to keep everything on the same page. So we had this statement as if, and then if else. So if C is greater than or equal to A, then and C is greater than or less than Z for the whole range of the alphabet, and if C is equal to A, or true or false, or C is true or false for E, or I, or O, or U, vowels, and it'll appear as this is a uppercase vowel. Else, then if it is an uppercase consonant. If the input is a lowercase letter through A through Z, then we're going to check if it's a vowel or a consonant. And if the condition is met, then we're going to display a message, and this is going to be treated as character C3. So building this, we're going to do the same as we did for the uppercase letters. Give a condition as if C is greater than or equal to A, and C or C is greater than or equal to Z, then we'll go and we'll see if it meets condition 2. Is C a lowercase vowel? If it is, or if it's a lowercase consonant, then it'll print the message for the vowel or the consonant. If C doesn't meet criteria for either the original case of a number, C2 or C3, then it will be allotted as a special symbol. So we're going to run this code. And from what we are given is we're going to try a character. And we see that it recognizes a special symbol. We are going to try a uppercase consonant, G, which is asked for in this case. We see it reads it as an uppercase consonant. We're going to do a number, 9, and we see that it reads it as a number. And we do a lowercase vowel, U. We see it reads it from the code as another lowercase vowel. Moving on to the last question, question 4. In this case, what the problem is in a semiconductor fabrication facility, wafers are tested for quality before being used in IC production. Parameters are the breakdown voltage must be greater than 50 microvolts, leakage current must be less than 0.7 milliamps, carrier mobility must be greater than 5,600 centimeters squared per volts per second. We have a grade that are given to the wafers, and there's certain conditions that must be met. So in this initial condition, we are declaring what we're looking for, which is breakdown voltage in 1, leakage current in 2, and mobility in 3. And we'll call these as exactly as they're termed from the problem set. And then we want to declare what our integers are, which is condition 1, 2, and 3, and then the grade. So we're going to print for the breakdown voltage, print for the leakage current, print for the carrier mobility. Once these values are scanned and determined, we're going to declare C1, C2, and C3, knowing that C1 must be greater than 50 microvolts. C2 must be greater than 0.7 milliamps, and C3 must be greater than 5,600. Structuring this for the if-then statement, we know that if C1 and C2 and C3 conditions are met, then it's a grade 10. Else if conditions 1 or 2 are met, then it's going to be a grade 9. If only C2 and C3 are met, then it's going to be a grade 8. If only C1 and C3 are met, then it's going to be a grade 7. And then if only the one condition is met out of C1 or C2 or C3, then it'll be a grade 6. If none of the above conditions are met, then it's just going to be a grade 5. Grade 5 is going to display if none of the conditions are met. We print this as whatever value, letter, grade, and then we're going to run the code. We noted the breakdown voltage is going to be 50, so we'll enter that. Milliamps are going to be 0.7, and then mobility is going to be 5,600. And as we were seeing in the sample runs, that we are going to have a grade 6 wafer, which makes sense after looking at this,